We're going to identify arithmetic and geometric sequences. And I want to talk about what sequences are. They're just a pattern of numbers, of terms, that are increasing or decreasing by a certain amount. With arithmetic, we are adding or adding negative numbers to each sequence. So if we look at the sequence A, we have 5, 8, 11, 14, and 17. And you want to figure out what's going on. So you want to look for a pattern. And what I normally do is I take the second number and I subtract it from the first. So 8 minus 5 gives me 3. And see, I want to see if it works for the next numbers. 11 minus 3, does that give me 8? Yes. 14 minus 3, does that give me 11? And you want to check it for a couple of times and make sure that that works for you. And so as you look at it, you can talk about the sequence and what's going on. And here in sequence A, we add 3 to the first number and we'll get the second number and so on. So we can find the next term if we wanted to. 17 plus 3 gives me 20 if I wanted to find the next term. And you could do the same for B and C and practice it. You can pause it and see if you get the correct answer. Now, I thought C was a little different because I'm okay with either. But arithmetic sequences, you are adding. Here you'd be adding a -2, but if you said subtract 2, that is fine with me also. Now, if you find a pattern where they're multiplying, or multiplying by a fraction, then that's called a geometric sequence. And in sequence A, you can check here. I can go 2 minus 1 is 1. Yeah. And then I'll try 4 minus 1 is 3. So the adding a number or subtracting a number doesn't work for this sequence. So let me try this. 2 divided by what number is 1? Well, 2 divided by 2 is 1. And I can try that in my calculator. 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. And so I am really multiplying by 2. Even though I said divide in this, I'm working backwards. So in this case, I was multiplying by 2. And the next one I think is a little harder because it's dealing with decimals and we're just not as familiar with it. But again, if you type in your calculator 0.06 divided by 0.1, you're going to get that it's 6. Your answer is 6. And then you can try it out. 0.06 times 6 gives you 0.36. 0.36 times 6 gives you 2.16. So it's a way of working around it if you don't remember your numbers. Same here. 16, and then I go to -8, and then I go to a +4. So you know if you're changing from negative to positive, back to negative to positive, then you're doing something with multiplying by a negative number. And then you can try it again. -8 divided by 16 gives you a -0.5. All right, so you're either multiplying by a -0.5 or I will take multiplying by a -2. Now I need you to be careful here because I need you to fix your notes. So I know that you're paying attention. Right here, that should be a -2. Okay, so make sure you correct that in your notes and you get a -2. All right, then we move on to the next slide. And on the next slide, we talk about arithmetic sequences. And you can see it's dealing with a chart here with a line graph. And arithmetic sequences go up a common difference. That common difference we use in terms of D. So when you see it on your reference sheet, you'll know that that's what's happening. What is the common difference? Well, the common difference in the previous slide in sequence A was 3. Adding 3 was my common difference. D equals 3. Okay? So on this one we look, and our common difference, we go from 1 to 4. So 4 minus 1 is 3. And we go from 7 to 4, which 7 minus 4 is 3. So that's your common difference is 3 on this one. All right, so here's some other examples. Remember the D is your common difference, and that's what you're looking for. And if I looked at this first one, which is the one that we were looking at on the graph, it's common difference of 3, so you're adding 3 to the next term. All right, this one you can look again. This one's getting smaller, so you know it's a negative number. You're adding a negative number. And you're decreasing by 5 each time, so the common difference is -5. And those are tricky because a lot of times we know it's 5, we just forget to put the negative in there, and then we make a mistake and get the wrong answer. right, so we're just looking at what these common differences are and determining if it's a sequence or, and if it is a sequence, what kind of sequence is it. Later on, in the next section, we'll talk about finding terms, and we'll use this formula right here below, the A of n. But don't worry about it right now. I just wanted you to have it as a reference in your notes. All right, geometric sequences means you multiply. Now look at the curve on this line. It's not a straight line like the other one and not a linear. This one has a curve in it, okay? Looks more like a parabola, all right? Just half of a parabola or half of a quadratic. Look at that. It's going up and getting higher and a bigger difference each time. All right, that's called the common ratio. And the common ratio, we use the term R, okay? R is the common ratio. So when you're looking at common ratios, if you go back to that previous slide that we were looking at and look at the bottom sequences where they were geometric, or 2 slides ago, I'm sorry, and they were geometric, we noticed that the common ratios are what you're multiplying by. So here the common ratio would be 6, okay? All right, so on this, again, you can look at them, you can practice, you can look at the ratios here. We just talked about it was 2, multiplying each term by 2 or dividing the second and the first term to find the common ratio of 2. All right, this one is -2. Remember my little hint at the bottom, if you're dividing, you're taking that second term, dividing by the first term. You don't actually have to see a multiplication or division or adding or subtracting. And again, here at the bottom, I gave you another formula. We're going to talk more about that in a couple of chapters, so don't stress, but I did want you to be able to see it, understand what we were talking about. A of n is just a term, a term in the sequence. A of 1 is the first term. R is that common ratio that we're going to be using, and n is the number of terms. All right, on this one, decide whether the sequence is arithmetic, geometric, or neither. Now I'm looking at this first grouping right here, and I want to think about it as, well, is it a sequence? So what I try to do first is I look at this second term. 1 minus a -3 is a difference of 4, okay? So I'm trying addition first. There's a difference of 4. Then I do it. 1 plus 4 gives me 5, check. 5 plus 4 gives me 9, check. 9 plus 4 gives me 13, check. Good. So that means that this is arithmetic, and it is a sequence. All right, then we try the next one. 5 minus 2 gives me 3. It's beautiful, isn't it? 5 minus 2 gives me 3. So I'm saying that this is a difference of 3. Well, 5 plus 3 gives me 8. Okay, so that doesn't work. So it is not an arithmetic sequence. So we try again. We try to figure out, well, let's do this. 5 divided by 2 is 1.5. All right, so 5 times 1.5, does that give me 10? No, because 10 divided by 5 is 2. So again, you're not seeing any pattern. You're not seeing a common addition or a common multiplication of a number. So in this case, this number of terms, this thing is not a sequence. It's neither geometric or arithmetic. I don't see a pattern going on. So it would be neither. All right, so what we want to talk about when we come to class is how do you know when an observed pattern forms a sequence? So this is your homework. Come think about it. Be ready to discuss this when we go into class. And what is the difference between arithmetic and geometric sequences? How do you know which one's which? Okay, that is your discussion when you come to class tomorrow.